Okay, as requested, I'm going to do problem 2b from the homework from before. Let's start out by sketching a graph and remembering what the problem was about. So we have y equals 10 minus mx, where m is the magnitude of this slope. So there's sort of two things that make this problem hard. The first is knowing how to set it all up and how to figure your way through the problem to the end. The second part is just keeping track of all the details to make sure you don't make an arithmetic mistake. So for the first thing, for actually being able to set up the problem, I think it always helps to make a picture, and then it always helps to label all the information that you know. So here's what we know. We know the y-intercept is 10. I'm going to call this value b, and I'm going to call this value d. And I know I need all of those because I know I'm going to be doing things with area and perimeter, and all three of those values are involved in area or perimeter. Okay, what I want to know in the end is m. I need to know what m is. So whenever possible, it's nice to set up equations that involve the quantity that you want to figure out, because then you won't have to substitute back in later. You'll just have that quantity and you can solve for it. So what else do I know at this point? I know that the area equals 2 times the perimeter. Okay. Another thing that you want to do is try and minimize the number of different variable names you're using. So I've got b to describe this distance, but of course I can rewrite that in terms of m, because you know that the slope should be sort of the rise over the run, so that's 10 divided by b. And of course this slope is negative, but because here I already have a negative sign in my equation, that means m should be positive, so I'm taking the positive value of that slope. So if that's true, instead of using b, I can rewrite b as 10 divided by m. So that's what I'm going to use in all my equations. All right, let's set it up. So the area is 1/2 base times height. So here the base is 10 over m, and the height is 10. And then 2 times the perimeter. The perimeter is the base plus 10 plus d. So the base is 10 over m plus 10. And then this d I can solve using the Pythagorean theorem. So that should be, so d squared should be equal to 100 plus b squared. So that means d should be equal to the square root of 100 plus b squared. But then I can substitute in for b, so that's really the same thing as 100 plus 100 over m squared. Imagine plugging that in for b and squaring it. Okay, so again, I'm writing the perimeter over here, so I've got those two sides of the perimeter. So now for the last side of the perimeter, that's root 100 plus 100 over m squared. All right, so now that I've set it all up correctly, I can kind of see it's going to work, because the only variable I have in this equation is m, which is exactly what I want to know. If you didn't set it up this way, you could still make it work. Like, you could have other variables that you substituted in to find the area and the perimeter. Only then you would end up solving for something else. Like, you might end up solving for b. And then you would have to use the value for b to figure out what is d. And then you would have to plug all back in at the end to figure out what m was. So I think sometimes it's easier to substitute at the beginning and then just solve directly for what you're looking for. All right. So now the second half of what makes this problem hard is you have to be able to sort of manage the algebraic complexity here. So let's start out by simplifying. Here I've got 100 in the numerator divided by 2, so that should be 50 over m is what this side simplifies to. I'll just distribute the 2 here. No, I'm not going to do that. I'm going to divide both sides by 2. So this 50 becomes 25. And then this side, when I divide by 2, I cancel. So now we've just got 10 over m plus 10 plus root, all that business. All right. What would be really nice is to get rid of this square root. So I'm going to move everything that's not the square root to the other side so that I can square both sides in order to get rid of it. So I'm going to subtract these two quantities. So I've got 25 over m, and I'm going to subtract 10 over m. So that should give us 15 over m on the left-hand side. And then I'm subtracting 10 from both sides. So now I've moved those two over. And then I've got that root of all that other business still. All right, great. So now I can square both sides. When I square the right-hand side, the square root goes away, and I've got 100 plus 100 over m squared. When I square this side, I guess I'll write it all out. So we've got 15 over m minus 10 times 15 over m minus 10. So if you sort of FOIL or distribute or however you think about this, I've got 15 squared over m squared. Let's see, this times that is going to be minus 150 over m, and 2 of those. So that'll be minus 300 over m. And then negative 10 times negative 10 is positive 100. All right, so it's getting simpler. I see 100 on either side, so I'll go ahead and subtract 100 from both sides, so those will end up canceling. And now I'm going to multiply everything through by m squared. So when I do that, I have 15 squared, which is actually 225, but if you didn't know that, I like to just keep things in the way that will let me proceed with my work the fastest, so I didn't want to interrupt myself to write that out. Okay, so I'm multiplying through by m squared, so here this is going to be 300m. I don't have 100 anymore, equals, and then this is 100. Okay? Cool, so we're almost there. I'm going to move the 300m to this side. I'm going to subtract 100 from that side. So I said 15 squared is 225, so 225 minus 100 is 125. So now I've got that m equals 125 over 300, and both the numerator and the denominator here are divisible by 25, so that gives us 5/12 is what m is equal to. And then if you wanted to go back and double check your answer, you would actually go back and calculate if this is what m is, what is the area, and what is the perimeter. And make sure that twice the perimeter equals the area, just so that you know that it works. And we did that in class, so I'm not going to do that right now. Okay, I hope this has helped. Good luck in the future.